Ladies and gentlemen, it is my pleasure to introduce to you Grant Rao. He introduces himself as a professional with 20 plus years experience in investigations, safety, quality assurance, regulatory compliance and safety case development. In one person. You started as an engineer for the asset integrity team with Shell as a student? 98?
Shell, yeah.
Right? Okay, yeah. We've been working for Bureau Veritas.
Yeah, in Scotland, and then I thought it was a bit too cold there, so
yeah.
Moved off to Australia, Southern Climate.
Yeah, so you've been working in Resilium for NOPSEMA
yeah.
as a health and safety regulatory specialist.
Yeah, so there was a new regulator for the offshore industry it got formed in 2005, and I decided that I got an opportunity with them in 2007 to join them, and I spent 11 years.
11 years, right, yeah. And now you are helping Tennet raise the bar as an offshore safety advisor. You're living in Limburg?
Limburg, yeah. I met my wife, my lovely wife, who's Dutch. And, I met her in Australia, and then she dragged me out here to colder climate again. And, and now I'm working for Tennet.
Yeah, I see a trend. I see a lot of sort of like the Dutch beautiful ladies being sort of taken by all these foreign guys. I don't know what's happening. So, but still, we love you, we welcome you as like a typical Dutchie.
Bit shorter.
Bit shorter, yeah. And I think funny thing is that you like to take risks, right?
I do.
Yeah, so maybe you like to expand a bit on that one before you head off.
Yeah.
You're going to be assisted by Jasper as well. And of course, Jasper is sort of, we are only, it's actually Jasper who does do almost everything, and we send the invoices. No, have fun?
Very good.
Yeah. Do you like to use the mic? Maybe.
Let's see.
I would say,
Let's try this.
yes.
Okay. So I do like to take risks. I did this year, well actually last year now, I did the mega avalanche, and I don't know if anybody knows that, but it's a downhill mountain bike race that goes for 37 kilometers all the way down. So I did a lot of risk management and put in place a lot of controls, and I made it down safely.
As well. It's a new company outing. Sounds good.
Yeah, that's the next company outing, exactly. So we discussed quite a lot of bow ties, and it was in operation. Ooh, bigger? Yes. Which one goes forward? Which one? Make an error. So now I would like to discuss bow ties in early design. So can we use them in early design? What's the benefits of using them in early design? So, and as you know, there's a big goal in Europe, and that is to be climate neutral by 2050. So the Netherlands and Germany has set ambitious targets for renewable energy. And also, the Netherlands, the Dutch people, took their government to court on climate change, and they won. Isn't that great? That's fantastic. I love it. So Tennet is a part of that. We're going into the offshore environment. We're building. We're now looking at building at least 6 2-gigawatt grid connection stations. That's actually a little bit different now because it's gone to 40. So, and what our scope for the 2 gigawatts are is you can see the 2 gigawatt platform, and then the cables to shore, and then the converter station. So that's the scope of the 2 gigawatt program, and it's a standard design. Wide, lesser resources. It's bigger than other ones. The 700 megawatt ones are just coming into operation now, and some of them are in the final stages of construction and commissioning. Lesser resources, reduced environmental impact, and of course, more energy to meet that transition.
Has it ever been attempted before, like a 2 gigawatt platform offshore? Or is it the first?
I think this is the first.
Right,
Yeah.
so it's, yeah.
As far as I'm aware, it's the first.
Yes. And then platforms at sea were already a thing, or they're being implemented at the moment?
Well, there has been the smaller ones, so smaller platforms, and then the larger ones have just been developed. So the 700 megawatt ones, the 900 megawatt ones are coming online, and this 2 gigawatt program is just using our knowledge and making them far bigger. So you only need 6 compared to having 40 400 megawatt platforms. So it really does make sense to make them a lot bigger. But there's a lot of risk in that. And you can see, sorry, I'm using an outdated slide, but that was the 6. That was 8, but there's actually now 14 confirmed 2 gigawatt platforms. At the start of this project, there was only 6 that we were going to build. Okay. So safety challenges, right? So you've got a new concept design. So there's risks in that. You've got high voltage transformer stations stuck in the middle of the ocean in the North Sea. Terrible environment. It's harsh, remote. More complex than the previous substations that we've done. So we required a bit of additional scrutiny on the major hazards. We wanted to look into them in a bit more detail. So, questions we need to ask. Do we know what can go wrong and how it can happen? What are the safety critical controls in place? The critical controls, well, we're calling them safety critical controls here, but yes, the critical controls. And are these controls sufficient to demonstrate that we are alarmed? Okay? So our 2 gigawatt platform, we must make a safe design. It's really important. Oh, I missed it there. Major hazards, often hidden until realized. Low probability, very high consequence events. Your background works against you on this. If you're an experienced operator, you don't normally see these events because they're so low probability. In your lifetime, you'll be pretty unlucky if you see one, and by that time it's too late. So you don't know how many barriers you're defeating by not doing the procedures as written, or any kind of barriers that you don't put in place or over time get degraded, and so you don't really know unless you have a look in depth. And when you start looking in depth, that's when you see the hazards and what could happen. And I don't know if anybody spotted, but there's actually a crocodile in that picture. Anybody see? It's pretty well hidden. That's your major hazards. Your personal safety hazards are pretty easy to see. You know, you do something a little bit dangerous on your mountain bike maybe, and then you get that feedback. Because maybe you crash or almost crash and you think, oh, that's a bit unsafe. I'm going to correct my behavior. With major hazards, you don't get that opportunity.
Where is it?
Ah,
On the right?
it's here.
Oh, where?
Yeah, it's It's a good one, eh? That's your major hazard there. Nice picture. So quite appropriate in Australia. You know, you gotta watch out for the crocodiles. You often don't see them. Okay. So, when we're wanting to do safety by design, it's best to actually start at the concept stage, because you can influence the design really easy. You just change the paper, so it's very cheap. But as soon as you start to go to detailed design, the cost goes up because you've already tendered it out, variations, etc. It becomes more difficult to change. And then during construction, installation, and then exponentially more expensive to cut steel and change your design. So it's really important to get it right, or as close to right as possible in this stage.
Even more so, I think, in this case, because it's like the first template that will have 14 copies of it, right? So
yeah, at least 14.
yeah.
So it was at least 6, now it's at least 14. So it's really important to get this design right.
Yep.
Perhaps I'll do it. I have not done one with the microphone yet, so let me do one with the microphone. We didn't start with creating the bow ties in the first place, I think. That it was already a process in place before that. We already did a design hazard review, or actually we didn't do that, I think it was done with the team. Can you tell a little bit about that, or?
Yeah, so what we did was we did our normal hazard as the main identifier for all the hazards on the 2 gigawatt. We did the HAZOP and other safety studies. But what we didn't do is we didn't do the bow tie, and there's certain reasons why we wanted to in this project. So this was not our normal process. So it was a bit of a pilot study to see the benefits of it.
Right, so the design hazard was already done in a larger group of experts in a room, larger spreadsheets, going through individual scenarios, basically looking what kind of things could go wrong, what kind of controls you should have in place. Similar information, I guess, to what you would do in a bow tie, but a slightly different perspective. Whereas hazard is very a structured process. You already go through a list of known scenarios, basically, go through them one by one in a very long, laborious process. But it's very detailed in that sense, but it focuses usually on a small part of the installation. So it's only looking at, it's breaking this whole big 2 gigawatt platform into very small little nodes, basically.
Little chunks.
Yeah.
Chunks
will be
of
analyzed.
hazards.
Yeah, that will be analyzed in and of itself, which of course is good because you want to look at it in that sort of detail. But it also sometimes misses certain larger risks that cascade into other types of scenarios.
Yeah, so all the major hazards, it's not just one barrier failure, it's multiple barrier failures. If you go and have a look at any major incident and map it out, it's a barrier failure after a barrier failure after barrier failure after barrier failure. So the bow tie actually allows you to map out what could happen and how it could happen. So it's really a powerful tool.
Yeah, but we did find like different things with bow ties than we did with HAZID, which is I felt was interesting because like HAZID also it does a lot of the same type of information. You do identify your controls, you do identify your scenarios, but still within the bow tie context we were able to find other things. Mainly I think because like bow ties tend to be slightly more free-form, so it's more opportunity to write out the scenarios as they happen, or like describe the scenarios basically in a more, I guess, organic way. And taking I think a more zoomed out perspective compared to what the HAZID in this particular project had done. So we did find some other cascading effects, for example, that we did not find before. And luckily they did already do a HAZID study, of course, because it was a valuable source of information as well for us when we're doing it. But because we did the bow ties basically with the two of us, mainly like we created the bow ties with the two of us based on the information that we already had, and then we fed back the information to the team of experts to see where we needed to adjust it. So in order to not spend too much time with, or spend too much resources with the people, these other subject matter experts, which already spend a lot of time doing HAZID, we did an additional review using the bow tie and then feeding back that information to keep it as lean and mean as possible.
Yeah, that's right. I think we had a really tight schedule, and also the project team did not have a lot of time, so we needed to utilize their time as efficiently as possible, and we came up with this strategy to provide feedback to the design team so that they could make any changes if we did find anything, because we didn't know that we were going to find anything major.
Yeah, so it was a bit of an attempt as well.
Yeah. Okay.
So also, yeah, I guess it's building on top of the HAZID study in a way, right? So it's not, we're not saying replace your HAZIDs with bow ties, we're saying there's different tools with different outcomes that can be beneficial.
Yeah, I mean, there's strengths in the HAZID process, everybody knows it, and there's also, but there's limitations, and you should be aware of those limitations when you go to do the HAZID and try and fill those limitations with other techniques that fill the gap.
Yeah, and this, the same is true for bow ties, of course. There's also strengths and weaknesses there.
Yeah, that's right. Okay, so when we were selling the concept and what we wanted to do, we also had a presentation, and because we wanted to show management why we needed to invest in this at a late stage of the project feed, and what the benefits to management were. And I think, you know, so we presented it, and part of the presentation was this visualization of what the bow ties can do compared to an example of a HAZID done in a previous project. So here you can see that the hazardous event is insufficient insulation. But then there's a whole load of other hazardous events grouped together, and then the existing controls are all grouped together, and further actions are grouped together, and then you've got this risk ranking, and it's so it's quite confusing what controls are related to what threat. And by doing the bow ties, you actually start to understand the link between the threats and the controls, and then you can start having a look at the different controls. And so this one we've got is a safety critical procedure that we're relying on, and this one is equipment, and another procedure and another procedure. So you can see all the controls to prevent that unwanted event. So it's very powerful to separate out the threats.
Yeah, in addition to that as well, so you can separate it by scenario, so you know which control really belongs to which scenario. But also we often found that it doesn't, like here it leads to a short circuit situation, but that's obviously not the end. That's in many bigger disasters, that would just be the beginning of it, and there would be fallout from that circuit malfunctioning into all kinds of fire scenarios which might be relevant on that particular location in the platform, and might have very different effects depending on which location in the platform it is. So that's also where, when you're identifying your consequences, you can think about, okay, what if the fire breaks out here, what happens with the oil, for example, that might be in the installation? Where will it go? Will it drip downwards, or what happens with that, basically?
Yeah, exactly, and you can see it on the next bow tie here, where the short circuit or electrical arc leads to a fire and explosion. That can lead to a large fire on the platform. So what are the controls to prevent all of that? And you can see from the start, you're going through all these barriers to get to that major hazard, and that's very difficult to think about when you just look at it in the hazard.
Could you have found the same information with the hazard? Maybe you could, but I think like just having the different perspective will open up other questions and other queries. I would say.
Yeah, it makes it, the bowties make it a lot easier to visualize what could happen. And then also the layers of protection, how many controls do you have in place? How effective are those controls? Is it an engineering control, or are we just relying on procedures and competencies? Do we need another engineering control to demonstrate a LARP? Can we put that engineering control in? So the approach and method of work. So
Yeah.
we actually did six. We chose 6 major hazards.
Yeah.
We did have a very limited scope.
I think we did it in roughly, what was it, 2 weeks?
Yeah,
2.5?
I think so. Yeah.
With the two of us in Corona period, so.
Yeah. So you see us having fun.
The first time I met Grant in Arnhem at the station, well, I could recognize it was him, but I always thought he was larger.
And do you know what? I always thought, you know, Jasper would be smaller. Because you don't. It's quite funny because you don't actually see how tall someone is.
Yeah. It says more something about how your webcam is angled, I think.
Yeah, possibly. But yeah, that's why Scottish students and then Dutch students. But yeah, so there was a 4-step approach. We prioritized the top risks for review only because of the limited time. And yeah, the lean 2-man team initially, and then afterwards, then we brought in the project team and their specialists to go over all the bowties that we had and all the queries, because we had quite a lot of action points identified while we were going through the process that we needed to ask them clarify. Yeah. And then we reported the findings. Approach benefits, I think, very low cost compared to having
the full team available all the time.
Yeah, a repeat of the HAZID basically. So that was good, and of course the limited project resources, because I know I would have definitely not got approval if I had suggested that we do another HAZID.
Yeah, with the whole team again.
Yeah.
But this was a great way, like a minimal effort approach to find the still like some things that can be improved, I would say.
Yeah, that's right. So yeah, we went over the presentation developed alongside the proposal to really sell it and to allow the management team to visualize what the benefits are and why we're doing this approach.
I think an additional thing that we did while we're creating the bowties was also to look at the design standards that should be applicable to installations of this type, and see how those design standards were actually being materialized through the 3D controls on those bowties. So which of these design standards were being implemented through these different controls. So we could also see if all the design standards were indeed incorporated in the platform at that particular level. But that was a bit of an exploratory, I think, exercise.
Yeah. We didn't. We started off and then we just developed as we went along, and during the sell to management, I said, well, what would you rather do? Would you rather us identify where you need to cut steel and change things later on in the process, or right up front when you're able to just change the paperwork? So that was a really a big incentive for them to go ahead with this project.
Try it.
Try it. See what you find. what did we find?
Yeah, a couple of things. Just a selection, I guess. But
Yeah, this is a selection of the findings. How many findings did we have? We had quite a few.
is it 16 or so? But of various degrees.
Various degrees, yeah. So some of the main findings, we're not going to go into all of them, was that we found that the bird cage was actually above the, and this is the high voltage cooling system, was above the primary muster area. And that could lead, if things went wrong, you could have hot oil coming down onto the lifeboat. So what was done about it? Well, they decided they'll just relocate the primary muster area.
And the facilities associated
Yeah.
with that. Yeah.
So try doing that after the design.
Yeah, I guess, yeah, so of course in the HAZID it was identified that these lifeboats were a requirement and that they should be of course in place. But there was not maybe a look at how would that control really work if it needed to happen, like in what context would it materialize and stuff like that. And I think within the bowtie we had thought about more like types of different scenarios which made that more apparent. I think that's why we caught that particular.
Yeah, and DNV ST0145 for the platform design actually mentions that they need to be protected against all foreseeable events. So that was a foreseeable event. The next one. So we found that the control room was located underneath the battery room. And the route from the control room to the general muster areas passed high-risk areas. So what did they do to resolve it? And again, try to do this after you've built the platform would be very difficult. But we decided that we would duplicate the control room, and we actually relocated it as well. So we had redundancy in the control room and survivability. And the control room was actually relocated next to the MLQ.
That's the crew quarters.
The quarters and the heli deck underneath. Okay. The next one was hazardous material storage, and as you can see, that was next to the living quarters. So that was the next one. We said, well, we don't really like that next to the living quarters, please move it. And they did. So that was good. Yeah. So it was a real, I think it really was quite a success. And if you multiply that by 14 platforms, the cost savings at the early design is really significant. The next one was the walk to work, and the walk to work is next to the diesel tank. So we had so where you access the walk to work system is right next to the diesel tank, and we thought, well, maybe there's a potential for collision and it piercing the diesel tank. So we highlighted the concern with the project, and they took it on board, but it didn't need adjustment. But it wasn't identified previously as a risk.
For those not from the offshore world, I guess the walk-to-work platform is the area where you would embark or disembark a ship, or the crew transfer vessel where you get onto the platform or onto the ship.
Yeah, and so there's a couple of types of walk-to-work. You can get the jack-up barges and then a gangway going across, or you get the active heave compensation system on a vessel, and then the vessel comes alongside the platform, and the gangway goes up, and it's heave compensated, so it stays in its place, and then the people walk across. So it's instead of relying on CTVs and people walking up the ladder. Yeah.
Walking plank.
Yeah. So it's a little bit safer, and it's got a lot of engineering controls.
Yeah, yeah.
Yeah. instead of reliant on procedural controls and competencies.
That's the team.
I think we've come to the end, actually.
Lisa?
Conclusion. Yeah. So yeah, we mentioned the costs would be significant, and even more so now that there's a lot more platforms that intend to be built. The method of work was very cost effective, small team, and then going out to the project team to get the information. And we completed the project. I think it was all pretty tight within the month.
Yeah.
We did a lot of bowtie sessions.
Online.
Online.
Yeah.
So sometime at the end, I think we were bow-tied out for at least a week.
Yeah.
And now what we did do within Tennet is we actually embedded the requirements for bow ties in our specifications for the platform tenders. Yeah. So it's now a requirement for all our contracts. So that's a really a great success.
Great. Yeah, nothing to add to that. Yeah, that was it.
Yeah. Is there? Any questions?
Does that mean you'll now do the bow ties first, or will they remain? Because it sort of feels like you use them as a bit of assurance of the initial hazard. Will they be done first now?
We will do the hazard, and then we will do the bow ties as well. So we're not going to get rid of the hazard process, because it's quite granular and focuses in on a small part, but the bow tie is the bigger picture, and we only do the bow ties for all the major hazards that we foresee, because it is quite time consuming constructing these bow ties.
Yeah. Absolutely.
Have you already conducted them on the existing platforms as well, or will you still do them?
No, we've started with the existing platform bow ties, but that was something that we still need to do and create the operational bow ties as well.
But any change that we would find then would have to be...
Yeah, it's going to be more costly.
Yeah, exactly. Yeah.
If we can't demonstrate a lot for certain risks.
No.
But hopefully we've not missed anything.
Yeah.
Any more questions?
I think you did well.
Thanks.
Thank you.
So it might not be a complete surprise, but I also want to thank you. You've earned it, stroopwafels and haas. Thanks, Grant.
Lekker.
Okay, yeah. Great contribution.